This is our product, using a 6-axis industrial robot to 3D print objects wirelessly. Now the idea behind this product is to expand the range of motion when 3D printing material and to break out of the Cartesian coordinate system and start printing out using curvilinear paths, which will strengthen the materials upon building.
The goal of the project was to create a wireless 3D printing tool that can be implemented on an industrial robotic arm. But instead, we created a platform for innovation. The objectives the team accomplished revolved around 3 major points: ease of use, quality, and safety. Our attachment is able to print out moderate to difficult models, but has room for development. The attachment is even capable of non-planar 3D printing and able to create shapes not even possible on Cartesian printers. Many design decisions were made to get to this point, and we're going to cover the primary ones.
During our project's initial concept and planning phase, we considered a myriad of options laid out before us in respect to communication between the 3D printer and the industrial robotic arm. Bluetooth, while easily accessible, is low range with low data bandwidth. A radio-controlled model is plagued with vulnerabilities which immediately eliminates it from use in an industrial setting. With both of these options ruled out, we landed on Wi-Fi. Wi-Fi allows for better bandwidth, better connection strength, server-level communication between the device and the user, and built-in security to shield against the risks.
In the block diagram, we can see the big 3 tag at the center of the device. The big 3 tag is the main processing power controlling all the components involved. A 24 volts DC power supply is used to power the system. The 24 volts is supplying power directly to the hot end assembly, the big 3 tag, and to the 24 volts DC to 5 volts DC converter. The 5 volts from the converter powers the Raspberry Pi. The Raspberry Pi functions as a communication board that creates its own private Wi-Fi network. We connect to the Raspberry Pi Wi-Fi network and use the auto-print interface to control the temperature and extrusion rate. The desired parameters are sent from the auto-print interface to the Raspberry Pi and then to the big 3 tag. The big 3 tag turns on the extrusion starter motor to supply the plastic filament to the plastic filling assembly. As the plastic filling assembly supplies the plastic to the hot end, the big 3 tag increases the temperature of the hot end. The result is melted plastic being extruded from the hot end.
To get started using the 3D printing tool attachment, we need to connect to the Wi-Fi network, broadcast by the tool itself. Once there, we can set the temperature of our tool head. We'll be using PLA plastic today, so we can set to 205 degrees Celsius. While it's heating up, we can then go to Robotic and get the robot motion path set up. We already have a verified setup created, and we can use that today to 3D print an object. Once it's all ready to go, we can then press the Go button on our KUKA pendant and get started.